Hello everyone, welcome to the video lecture series on Simplex Method. I am Professor Mayur Sir. In this video lecture, I shall be discussing about the questions how to find the basic solutions of an LPP when it is given to you, or how to use a trial and error method. So how to handle these kind of questions, so let us see in this video lecture. I'll take up a very simple and a very standard question which can be asked in the examination. So let me give you the question here. The question is, find all the basic solution for the given LPP below. So now let us see here the question. So the question is, now maximize Z, which is 3x1 plus 4x2 subject to x1 plus x2 is less equal to 450, then 2x1 plus x2 is less equal to 600, and x1 x2 is greater equal 0. This is the question given to us, and we are now asked to find all the basic solutions for this. So let us see how to handle this. So the first thing over here, we first need to convert our given question into standard form. Okay, so we write here, we write the standard form of the given LPP. So the standard form of the given LPP is, therefore the standard form of the given LPP is maximize Z as 3x 1 plus 4x2. Now we need to put the slack variables. Okay, subject to the constraints are going to be x1 plus x2 plus s1 less equal, which is there, that sign will get converted to equal to 450. Then there will be 2x1 plus x2 plus s2 equal to 600, and the non-negativity conditions would be x1 x2 s1 s2 all are greater equal to 0. So these are the conditions that we have. Now we write down over here total number of variables is equals to m plus n, which is equals to 4, right? And there are m constraints. There are m constraints. So m is, which implies here m is 2. There are m equal to 2 constraints. You can call it here, you can write down here this way. There are m equal to 2 constraints. You can write like this. So m is equals to 2. Therefore m plus n equals to 4. So n is equals to 4 minus m, which is 2. So here you have n equal to 2. Now the number of solutions that we can have. So the total number of basic solutions, therefore the total number of basic solutions is given by m plus n choose m, which implies it is m plus n factorial divided by m factorial n factorial. So therefore, which implies here 4c2, which is 4 factorial divided by 2 factorial 2 factorial. So this is going to be 4 into 3 into 2 into 1. Here it is going to be 6. So there are 6 such answers we will be able to get. Okay, now we need to make a table that will help us to understand the whole process of getting the answer. So I'll insert a table over here. I'll insert a table that is needed. First you can check out how many columns are needed and what all things are there. So I will need 8 columns, basically 8 columns I will need, and I will need 6 solutions are there plus 1, so 7. So 7 rows I will need. I'll need 7 rows and 6 I'll need 1 2 3 6 8 columns. Okay, so here we have the table, and now the following thing we will write down here: serial number, and then there is basic solution. We'll write down. We'll just put. I'll increase the size of the font over here to, let's say, make it 18 or 20 would be better. Let's say still bigger font I'll put. Yeah, this would be good. Basic solution, the basic variables rather, basic variables. Then we will need non-basic variable. Then next we will need here value of the basic variables or on solving the conditions that you get. So for this you can label as this way. you can write down here. So if we write here something like equations and the values of the basic variables, yeah, equations and the values of the basic variables. Okay, that would be the one column, and then we will need value of the objective function. Okay, value of the objective function z. The next one, is the solution feasible, or is the solution, yeah, is the solution feasible, that would be required. Then next what we would need is the solution non-degenerate or degenerate, either one you can take. Is the solution non-degenerate, that is okay. And the last one we will need is the solution feasible and optimal. Is the solution feasible and optimal. So all these things we will need, and yeah, so I'll just have this columns established properly. Once we are done, we will be able to write all the stuff here. Yeah, is the solution feasible? Yeah, then there is this. Yeah, is the solution non-degenerate? That is also a thing. Yeah, and this one. Alright, so we have got all these columns ready for us, and now we are in a position where we can write down. So here, before writing down the table here, we can write down here the following table gives the summary of the characteristic of the various basic solutions, something like that. So here we can write insert, I'll insert some space. Yeah, here we can write the following table gives the summary, or gives the various basic solutions. You can write down this easily, and this can work. Now we have this, and so let us see how to handle this. So the first one we have here. Now when we are declaring the basic variable and the non-basic variable, so we go by the definition of the variable. So first we will have to choose some variables to become 0. So which all variables will become 0? The non-basic one, okay, or the basic ones, whichever you want right now. So see, as per the definition that we had taken, in the previous video that we had seen, the basic solution, a basic solution is obtained by setting any n variables equal to 0. Okay, those n variables that we set to 0 are called non-degenerate variables. So we first non-basic variable rather, sorry, non-basic variables they are called. So we will be taking those variables first. Okay, so you can write down non-basic as first, then you can take down basic. That would be good thing. Non-basic variable we write down first and then the basic ones. Yeah, this works better. So we first write down non-basic variable. So our choice for n we have to see. N is 2. Okay, we have to choose two variables at a time from the given formulas, or from the given expressions of equations that we found. We have to choose two variable. Why that they are two? Because we told that these are two, because m plus n is 4 and m is 2, it implies that n is 2. So we have to choose any two variables 0. So for the first case in here, I will choose s1 and s2 equal to 0. s1 equal to 0 and s2 equal to 0. The moment I choose s1 and s2 equal to 0, I get the basic variable automatically will become x1 and x2, right? So the basic variables are now x1 and x2. The equation that we get over here by setting the two s1 and s2 0, we get here it is x1 plus x2 is equals to 450, and when we choose 2x1 plus x2 here, this is going to become 600. So we will have to solve this. Now this is basically a simultaneous equation, right? So on solving this simultaneous equation, what do we get here? We will get x1. I'll use a different color pencil pen here. Maybe let's take up some purple. Yeah, x1 we will get here 150, and x2 you get somewhere around 300. That is what we get. Now we calculate the value of the objective function z. So the value of the objective function is going to be as per the formula 3x1 plus 4x2. So it is going to be 3 times 150 plus 4 times 300. So that is going to be, total is here, it's going to give you 1650. Okay, that is the value you will get. Now when you substitute, is this solution feasible? Yes, this is a feasible solution. Why? Because the feasible solution, when we had defined, feasible solution said that they should satisfy the constraint. Yeah, because they are satisfying the constraint, and they should satisfy the non-negativity condition. So yes, this is a feasible solution. So our answer over here is yes. Okay, we write here yes. Is this solution non-degenerate? Yes. Now what is the definition of non-degenerate solution? It is a basic feasible solution in which all m variables are positive, right? All m variables are positive and the remaining n variables each are 0. So all the s1 and s2 both are 0 and the remaining m1 m variables, so x1 and x2 are positive we got, so this is a degenerate solution. Is this solution feasible and optimal? We have to wait, because optimality will come when we come to know the maximum answer. So let us wait for the last column. So now we fill up the second year. So second year we will fill up. So now comes the next choice. What will be the next choice? Let's say x1 equals to 0, x1 equal to 0 and s1 equals to 0. Now when x1 and s1 are 0, so what are the basic variable? Basic variables are x2 and s2. Now the solution, in this case the solution for the equations that we get, so the equation will become here x2 is 450 from the first one, x2 becomes 450 automatically, right? And no, wait, we have to see what happened here. x1 is 0, s1 is 0, we have taken 2, s1 is 0, x1 is 0, so x2 is 450, correct? Yeah, x2 is 450, x2 equal to 450. What happens to the next one? x1 is 0, we have x2 and s2 equal to 600. Yeah, so x2 plus s2 equal to 600. This is what we have. So this means s2, we will have to calculate, this will become 150. Okay, both are positive. Now when we go for calculating the value for objective function, the objective function will become 4 times 450, right? So that will give me the answer equal to 1800. This is one answer we get. Now, is this a feasible solution? Yes, it is a feasible solution because the conditions are being satisfied, so we say yes. Is it a degenerate solution? Yes, it is a degenerate solution because the variables, each of the n variables are 0 and the remaining are positive. So yes, it is. Now optimality, the last column we will be able to fill it at the end, not now. Now the next one we take, the third one. Let us take the third one. Here, so here you have, once we have taken s1 0 x1, so now we can take x2 equal to 0 and s1 is 0. So the variables that will be the basic ones, now they will be x1 and s2. So basic variable will be x1 and s2. So let us see the equation. In the equation, when we substitute here, s1 equals to 0 when we say, and x2 equal to 0, what do we get? The equation will turn down to x1 and S2 we need. Only S1 and S2 will be there then. In that case, we will have x2 0, so x1 plus, so here there is x1 equal to 450, and in the second equation what will happen? Second equation, x2 is 0 and s1 is 0, so we will have 2x1 plus s2 is equals to 600, right? So, and on solving this I will get s2 equals to minus of 300, right? 900 and that is 600, so that s2 is minus of 300. Now the value of the objective function, even if I calculate here, it is not going to support our answer. Even though we calculate it, let's see, s2 is not there in the objective function at all. So x1 value what we got is basically, even if we don't calculate it here, you can put it dash, because this is not going to affect our answer. Okay, this is not going to affect the answer, but still let's say 4 times 450, but this is not going to be the case. I'll tell you why. Now, is this a feasible solution? Is this a feasible solution? No, the solution is not feasible, because one of the variable, the slack variable or the surplus variable, which you can call, is gone and have given us a negative value. So this is not a feasible solution, so the answer is no over here. Now, is the solution non-degenerate? No, it is not a non-degenerate solution, because what has happened, x2 is become 0 and s1 is equals to 0. Here these are 0, but here x1 and s2, one answer is negative, they both should come positive, only then we can say yes. So this is not going to work. Now next one, here we did not calculate the answer. The next, the fourth one, for the fourth one we will now take x1 is 0, x2 we are done. We will now take here x1 equals to 0, s2 equals to 0. So in that case we have x2 and s1. So the equation in this case becomes x2 plus s1 is equals to 600, no, equals to 450, and when s2 is 0, and so x2 equals to 600, yeah, x2 is 600. So again here we get s1 value is minus of 150, right? x1 is gone 0 and s2 is gone 0. So again this is not going to be a solution of requirement, but we will have to say again this is no. Now the last case, the next case here, second last case will be the fifth one. Here the fifth case will be, we have got all those there, right? The fifth case will be, those are zeros, those are zeros, we are done with that. Now the next case we take x2 over here. x2 is equals to 0 and s2 is equals to 0. Now when x2 is 0, s2 is 0, we have x1 and s1. So in that case the first equation is going to become x1 plus s1 is equals to 450, and in the second case 2x1 is going to be equals to 600. So here we have x1 equal to 300 and s1 will be 150. Yes, now this is a solution which we can work upon. So here we will have objective function to be having the value of, the first one is 3 times 300, right? 3 times x1 plus 0 times s1 we will have to take, so it is 150. So the final value is 900 over here. So is the solution feasible? Yes, the solution is feasible. Is it degenerate? Yes, it is a degenerate solution that we get. Now the last one that we will have here, when x1 and x2 both are there. So the last case is x1 is equals to 0 and x2 is equals to 0. So what we will have over here is s1 and s2 as the two variables. So when we have s1 and s2 as the two variables, so the first case itself, it will directly give us s1 is equals to 450 and second case s2 is 600. That's what we will get. Now is this solution a feasible solution? Yes, it is a feasible solution, but the value of the optimal function, the function that we are optimizing, will be 0, because in the standard form the coefficient of s1 and s2 is 0, 0 s1 plus 0 s2. If you want, you can write it. If you don't write that, also it is okay, because the function is not going to be affected there. So that is what we get, right? Now is it a degenerate solution and optimal solution? Everything in this case also it is yes. Yes, because they are positive and these are zeros. Now we have to check which is the optimal. Feasible, so all these solutions were feasible solution, so your answer will be strictly no. Okay, in the no cases we will always say no here, because it is not going to optimize the function, neither it is a feasible one. So here these two cases are already discarded. What about the one we were maximizing the function? So maximization happens when the answer is maximum, so only that value we will choose now out of the three which is maximum. So 900, 1650 and 1800, so we will choose 1800 as the final answer, which is maximum. So yes, it is yes over here, and rest all places no. will be the answer, because optimal solution is only one in our case over here. Okay, so hence all other answers will be no, and this is the final answer. So final answer in the solution, when we see here, what do we get? So therefore the final answer is from the trial error method. This is also called the trial and error method. So the values that we got were, the values that we get, x1 was set to 0, x2 we got 450, and z maximum we got 1800. Okay, so this is the solution for our LPP. Okay, so this is how it works. So this is a very big table in order to make, so but this works and it is very easy. You can remember the headings and you can find out all the one at one time. Okay, this is how the entire question is to be done. I hope you followed this one simple example. I will take up another example in the next video lecture. Thank you.